Hello everyone, welcome back. Today we're going to be solving Leetcode number 15, three-sum. Given an integer array nums, return all triplets, nums I, nums at j, and nums at k, such that I is not equal to j, I is not equal to k. Basically, none of the indices are the same, and that the values at all those indices, I, j, and k, sum up to equal 0. This solution set must not contain duplicate triplets, right? So all the, so you can't have like, -1, -1 and 2, and -1, 2, and -1, right? The ordering of them doesn't matter. It has to be a unique combination of values. So we're going to run through this here real quickly with a excalidraw. This is a pretty simple one. Like I mentioned before, right? You have to all equal up to 0, and none of the indices, can have the same value, or basically can't have duplicate values in the result array. So the brute force way to solve this would be just to try all the combinations where the indices are different. You basically just use like a triple nested for loop. As you can see, I did like a small little example right here. So you would just say, for I and range of length of nums up to 2, right? Because you need 3, so you want I to go up to its final boundary, which would be the third to last number. And so basically in this case, you want to, do that triple nested for loop, right? For I, j, and k, you basically just, I and j would start at the beginning, at -1 and 0, and you just iterate k. Then you would, move j up 1, iterate k again, move j up again, iterate k, etc. You would try all the possible combinations with -1. You'd move -1 up, and then do that same thing for all the different combinations of j and k that you could do. Right. So this is going to be a big O of 3 time complexity. I'll add that right here. Right. So the complexity for this would be a big O of n to the third, right, for a triple nested for loop. So n cubed. Basically, however long, the nums array is. And obviously, like I said, they have these, small constants in here like -1 and -2. But, when you're doing big O calculations, you reduce those down, or you simplify those down, and it would just get, big O of n to the third, right? So the optimal solution for this, though, would be using a 2-pointer strategy, right? Or in this case, 3 pointers. But a 2-pointer strategy, I kind of broke it down here into kind of like 3 steps, or against how I think about these things. So a 3-pointer strategy is basically when you create 2 pointer variables at specific indices, or in this case 3. You use those values at the indices in some sort of calculation, right? So you take the values at these pointers, right? You use them in a calculation, and based on the results of that calculation, you'll learn some information about the indices relative to the target you're trying to reach, right? And then based on the value, or based on the sum, or whatever kind of calculation you're doing with the values at those indices, you would move the pointers up or down, right? And so usually in these problems, if you're given an input array, you want to sort that array, because it basically allows you to make some decisions based on your result, whether you can reduce or increase that result by moving the indices, right? And that's exactly what we're going to do in this case. So the first step to solve this three-sum problem in the optimal sense with this 2-pointer solution is to sort the array. Okay, so sorting is usually a log of n, kind of time complexity, and so hopefully that isn't the largest thing in your calculation, but that usually takes that amount of time, especially if you're going to use like built-in sorting methods, like the dot sort method in Python. So in this case, I see that, or I can show you here that we have already sorted this array, right? So -4 is at the back, and 2 is at the end of the array. So we're going to initialize I at -4, initialize J at -1, right? 1 ahead of I. Then we're going to initialize K at the end, right? And so if you notice, right, what we now have here, because we sorted this array, we know that when we add these values up, right? So -1, -4, and 2, right, we're going to get -3. Well, -3 is smaller than 0, so we want our sum in this case to increase, right? And the way we would increase our sum, given what we know about this array and these pointers, now that the array is sorted, we can increase our sum if we move j up, right? Because j is going to start at the next smallest number, right, to I. And so if we move it up, right, theoretically we're going to be increasing. Now sometimes it's maybe the same, but it's at least going to be equal to, if not greater than, the current value of j, right? So we do this calculation, we would get -3. We would see that we need to go up 1, so we would increment j, and go forward from there, right? So we would move j up 1 to -1. It would kind of be that same result. So we would end up doing the same thing, move it up to 0, right? We get that same thing. We would move it up again, right? Still, it's -1, right? And so then they would be on the same thing. And so we would break that loop, and then we would basically move our I up 1, move our j up to right after I, and keep k at the same spot. Do the same thing, and now here we get 0, right? Negative 1 and 2 is equal to 0. So we would add those in, add those to the result array. So we would add the combination of negative 1, and 2 to the result array, and then we would continue. Now, one important thing to know when you are actually doing these, and hopefully I believe there's an example in Leetcode that I can show you for this. But sometimes when we actually do find a combination that's equal to 0, we need to actually increase our j again, right? And this is basically for cases where j is going to be equal, the j that we just moved, the value of j that we just incremented, right? So we just incremented up 1 in this case where we found this 1, 1, and 2, right? When we increment this, it could be the same, right? And so in that case, right, since the numbers have to be unique, we need to continue moving j so we get a brand new number that we can calculate off of. Otherwise, we would just get a duplicate set and violate our constraint of the problem. So one also additional optimization that I'll show when I do the coding here in a second, when you're setting I, right, if the values of the first m numbers are the same, right? So say we had an array where it was just like 3 negative ones in a row, right? Well, again, understanding that we can't have duplicate values, we actually can actually optimize this array by moving our starting I up to the last value, the last occurrence, right, of that value in the array, so that way we're not going to be again using duplicate numbers and combining the constraint, right? So so that's kind of all that there is in the kind of explanation of this problem. So I'm going to go over to Leetcode, code this up, and see you there. We want to. All right, so here we are in Leetcode. We're going to type this up really quickly based on the explanation that we just did. So the first thing we want to do is create our result array. The next thing that we want to do is sort our input array. And then from there, we want to start with the setting of I in this kind of top level for loop that's going to control the whole thing, right? So we don't do for I in range of the length of nums minus 2. Right? Because we always want to go to that third to last number because, again, we need 3 elements in our array. First thing we want to do is check to see if I is equal to the value that is currently before it. Right? So like I mentioned before, they could have multiple starting values that could be equal at the front of the array, and we can't use duplicate values in this case, so we need to increment it. So the first thing we need to do is check to see if I is greater than 0. And if I is greater than 0, and nums at I is equal to nums at I minus 1, then we want to continue. Right? I just want to go past this loop. All right, next thing we want to do is set our j and k values. So j is going to be equal to I plus 1, or not minus, but equal to I plus 1. K is going to be equal to the length of nums minus 1. And then the next thing that we want to do is do our while loop. So while while j is less than k, we want to do calculate our current. So we do current equals nums at I plus nums at j plus nums at k. And then we want to start checking this value of current to see what order we need to move. So if the current value is less than 0, right, then we need to make it bigger. So we would do j plus equal 1. Else if the current value is greater than 0, then we need to decrement our value. So we need to do k minus equal 1. So we make that total smaller. And then else, this means that we found a current or a combination of these the values of these 3 indices that are equal to 0. We want to append to our result array. So we do res.append a new array of this right here. So nums at I, nums at j, and nums at k. Right, yep, that looks good. And then from there, let's increment our j up 1, right? So we get a new unique value. And like I mentioned before, in some cases, right, the j that we just moved up to is going to be equal as the value of j that it was just at, right? So I want to check that to say, again, while j is greater than or less than k, rather, and nums at j is equal to nums at j minus 1, we want to continue incrementing our j value, so j plus equal 1, right? And then from there, we would just return the result at the end, return res, and give this a look over. So yep, setting our result array, sorting it, going all the way up until the third to last value in nums. Check to see if the current value of I is equal to the one that was just before. So we move forward. Then we want to increment our pointer values, are the 2 pointers j and k, j right after I, k at the end of the array. And then we want to, loop while j is less than k. So while j and k are not on the same element, calculate our current value, check its results, and move our pointers accordingly. And then if we do find a valid combination we want to append to the result array, move j up 1, and then also check j again to make sure that we're not adding duplicate values. So this seems to be correct, so I'm going to run this here. Awesome, right? So testing is working, hit submit. And there we have it, right? So pretty middle tier solution, right? Beats 41%, but this is a pretty easy solution that you can use in the case of coding interviews. Hope you had a great time watching this video and learning a little bit. And I'll be back with another video very soon.